Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to start chapter number 12. Yay! We almost made it to the end of the book. Chapter 12 is the last chapter. We're going to be in lesson number 1. That's on page 552. Page 552. All right, what are we going to be talking about in chapter number 12? We're going to be talking about an introduction to statistics. What is statistics? That's an interesting word. I mean, is statistics singular or plural? I've never really looked into that too much. So we're going to say statistics are. All right, we're going to consider it plural. The study of techniques to collect, organize, analyze, and interpret numerical information. In other words, you have information that comes to you in the way of numbers. This could be anything: sales for a company, temperature, height, batting average for a baseball team, whatever. I mean, you think of it, it's any type of numbers that come to you. And statistics is a way to collect those, to organize them, to analyze them, and then to interpret them. So that's what we're going to be learning here in this chapter, different ways to accomplish this purpose. All right, what are some branches of statistics? There's really only two branches of statistics. The first branch of statistics is descriptive statistics. And descriptive statistics are used to summarize the main point of the data collection. Okay, let's use temperatures. And you have collected the temperatures, the average temperatures for something, for a city during a certain month, for whatever. Well, in descriptive, you are just summarizing the main points that you collected. You're not really going too in depth into them. You're more just giving the highlights. You're taking certain pieces out of it and saying, okay, this is a description of the data. In inferential, number 2, we use this to draw conclusions about the data. So in other words, if you've collected data about temperatures of a city, you would use inferential to say, well, I think that if it has been this temperature throughout this month, then next year during this month, it will probably be the same basic temperature in this city. You're making an inference about something. In other words, you're trying to interpret, or you're trying to say a little bit more about what you think might happen. You're trying to make a projection about the future or even the past. You're saying, well, I think that this probably happened in the past because of this data right here. There are several groupings within statistics, and I want to talk about the groupings. Really the first two, actually 1 and 3, are the two groupings, and some of the other ones just talk about the groupings. The first grouping in statistics is your population. Your population is the entire group. And this is kind of easy to think about, because what is the population of the world? What is the population of the United States? What is the population of, you name it, wherever you are? What the population is the total number of people that are in that state, in that country, or in the world. So population. The second one, think about this. If you're doing numerical study, let's say you're doing a numerical study on the world, are you going to be able to survey all 7 billion people that are in the world? It's not going to happen. And if you look at number 2, the census is the study of the entire group. In the United States, every 10 years, they do a census. The census is a study of the number of people that live in different places. What cities do they live in? Do they live in the country? How many people are in their home? All these different things is collected by the census. But they are studying the entire group. It's such a big undertaking that they only do it once every 10 years. This is not something that you want to do every day, because the population is too great in the United States to be able to poll them or to be able to ask them questions every single day. So what do we do when we want information about the population, but we can't really spend the time or the money or the resources to ask the whole population the question? Well, we do what's called a sample. Number 3 is a sample. It's a portion of the group that you're studying. So you just take maybe 2,000 or you take 5,000 people and you poll those 5,000 people. And as long as you get your sample randomly, as long as you don't like go to like the same place, you couldn't go to like a church and poll 1,000 people and think that that's going to give you a good sampling for the whole country. You're going to have to poll some people in this location, some people in that location, some people over here, some people over there. And what that'll do is if you take a big, what's called a cross section of people, then you will get an accurate, at least sort of accurate idea about the whole group or about the population. In statistics, sample size is the total number that you sampled, the total amount that were part of the part, okay, not part of the whole, part of the group that you sampled, and that's called sample size. And that is denoted by n. So anywhere that you see in statistics, you see an n, you should think sample size. Number 5 is the variable. Let's talk about the variables. These are a little bit different than algebraic variables. The variable is the characteristic that is being studied. So with population, the variable is like the how many. How many people are there? We need to study this to find out how many there are. That's the variable. That's the number that can change from year to year. Typically, this is going to be a number because, again, this is numerical data. So the variable is going to, but you don't know what it is. That's why it varies. It goes up and down. So we're not sure. So we're going to call it a variable. But variables can also be what's called qualitative or qualities about the numbers. So blue shirts, the number of people wearing a blue shirt. The number is a variable, but also the blue shirt itself could be a variable. You can have different types of variables. They can be words, they can be numbers. So in A, you have quantitative variables. Those are variables that are described using numbers. You're talking about just numerical information. Qualitative variables are variables that you cannot use numbers to describe. Like I can't use a number to describe a blue shirt. It's blue. It has to be described. It has to use words. So that's qualitative. And the way to remember this, quantitative sounds like quantity of something or numbers. Qualitative sounds like the quality of something, or you'd have to use words to describe the quality of something. So you can kind of use those words to figure out what those two things mean. On page 553, you're going to see example 12.1. What I'm going to do is I'm going to share a little sentence here, a little piece of the story, and then we're going to say, okay, what is the population? What is the census? What is the sample? What is the sample size? What is the variable? We're going to try to answer those 5 questions about each one of these little stories here. All right, Frank measured the diameter of 6 maple trees in the woods near his home. All right, so here's Frank, and he just goes out into the woods, and he chose just randomly 6 maple trees. He said, okay, that one. I'm sure there's more maple trees than 6 in the woods, right? But he chose 6, and he measured the diameter. What does he want to know? He wants to know kind of what all of the trees in the woods are, what are their sizes, their diameters. But he doesn't need to measure all the trees. He samples 6 of the trees, and that should give him a good idea. It's not going to be exact, but it should give him a good idea. That way he doesn't have to measure every single tree in the woods. All right, so let's go up here. What is the population that he is studying? The woods. He's studying the woods. He's studying maybe maple trees in the woods, but he's studying the woods. What is the census? A study of the entire group. So what's his census? His census is his studying of the entire group. Did he census? He did not. He did not go to every single tree in the woods. He did a sample, number 3. All right, so what was his sample? He sampled 6 trees. So really his sample and his sample size are kind of one and the same. You could just describe both of them by saying 6 trees or 6 maple trees. Number 5 is the variable. So what was his variable? And I guess the diameter is the variable, because that's the thing that was changing. The maple trees remained the same, but the diameter of the trees changed. Now, is that qualitative or quantitative? Well, it's quantitative because the diameter is measured, and so numbers would tell you what the answer is, like 6 inches, 5 inches. Do you remember this from the last lesson, from the last chapter? Continuous means that it's measured. Discrete means that it's counted. So this would be a continuous quantitative, because we're measuring something. All right, next we have Maria. Maria is letter B. Maria wants to know which eye color occurs most often at her school. So during lunchtime, she asked about 20 students what their eye color is. All right, so let's talk about Maria's survey here. What is her population? Well, you know, that's an interesting one. So I guess since it says she wants to know about the kids at her school, I guess I guess she doesn't want to know what everybody's eye color is. She just wants to know the people at her school. So the population would just be limited to her school, since those are the only people that she wants to know. Next, what is she doing, a census or is she doing a sample? Okay, she's doing a sample because the census would be if she talked to everybody, but she only sampled a certain group of people. How many? What's her sample size? Well, there was 20. And what would the variable be? Well, the variable is eye color. Now, this is one of those ones where I guess, yes, you could talk about the number because she's going to get a number. She's probably going to get like 12 blue and 6 green and 2 hazel, whatever. She's going to get a certain number on each one. But really, this is a qualitative survey. So she's talking about color rather than talking about quantity. She's more concerned about color than quantity here. Okay? All right, the next one, the last one. Billy has 5 ties and wonders if he has more or fewer than the other men at his college. He finds 10 other male students after chapel and asks them how many ties they have. What is the population? Well, the people at his college. Does he do a census or a sample? He does a sample. And what is his sample size? Well, he talked to 10 people. What are the variables? Well, it's what are they studying? He's studying ties. And again, this kind of comes back to qualitative, quantitative. Ties are more quantitative because it's how many is what he's looking for. He didn't ask them about the color of their tie or what kind of tie, bow tie, anything like that. So he's just concerned about the number of ties. And so this would be quantitative study that he's doing. And would this be discrete or continuous? Remember, continuous is measured, discrete is counted. Ties are counted, not measured. So this would be discrete there. Okay. Go ahead and turn the page over to page 554. We're going to talk about mean, median, and mode. We're going to do them backwards. We're going to do a mode, median, and mean. What is the mode? I kind of came up with this word all by myself. I say that the mode is the mostest. The mostest. Now, that's not a word, but I like it. Why do I like it? Because it kind of really sticks out in our mind that the mode is the one that happens the most, the mostest. Now, if we have a group of numbers, any number that occurs multiple times would be, kind of part of the mode. But We don't want any that just repeat more. We only want the ones that repeat the most. All right, so let's say that one repeats 4 times and one repeats 3 times. Well, the one that repeats 4 times is the mode. What if 2 numbers repeat the same amount of times and they're the most? Well, then there would be 2 modes. That's called bimodal. If there's 1 mode, it's called unimodal. What if there's more than 2? It's called multimodal. And sometimes maybe there's no repeating numbers at all. There's just all numbers that don't repeat, just all unique numbers. And that's called no mode. And that is on page 554. Next page. I'm not going to really spend a lot of time here because you guys know this stuff. We've done this year after year, and you should know all this. Median. The median, you can look in the book if you need more help, but I think you guys know this for the most part. The median. The median is the middle. I'll put middle on this one. So if you rank all of them, ranking means to put them in order. So if you put them in order, so let's say 1, 5, and 7. We put them in order. The one that's in the middle, the 5, is the one that we're worried about. What happens if there's 2 in the middle? Well, we take the 2 that are in the middle and we average them. So we say 5 plus 7 equals 12. 12 divided by 2 is 6. 6 would be the median for this one. So sometimes you have to average those 2 middle ones, but the idea is that you take the middle ones. They do give you a little formula here, and the formula for finding it, let's say you have a huge group of numbers and you don't feel like counting all the way to the middle, you can take n plus 1 divided by 2. If you take n plus 1, divide it by 2, what's n? N is the total number in your sample, and then you add 1, divide it by 2, that will give you your middle number. Doesn't give you your average, it tells you where your middle number is. So it'll tell you, okay, the 16th number is your middle number, something like that. Next, the mean. What does mean mean? Okay, well, I've always told you that mean means average, okay, and it does. But now that we are in statistics, mean, we're kind of stepping up our game. You are never going to hear the word average anymore, okay? Here's what you're going to see in statistics. You are going to see it is X with a line over the X, and that is read X bar, X dash bar. Whenever you see X bar in statistics, you need to think average. How do you find the average? You add everything up, divide it by the number of items in the list. And that doesn't change. The only thing that's changing is now we're going to use X bar. The other thing that I kind of want to show you right here is when I say add them all up, now we can put sigma them up. What does sigma mean? Sigma means to add. It's a sum. So sigma of X. Okay? And then we would divide sigma of X by the number of terms. So sigma of X divided by n equals X bar. This right here is the statistical formula for finding the average. Some of you are like, whoa, I think I'm just going to add and divide by 2 or divide by the number of things. Exactly, because that's what I just told you to do. If you're thinking you don't want to do that, well, it's what I said. It's the adding up, that's the sum of your numbers divided by the total number gives you your average. So you're saying the same thing that I'm saying. This is just the way to write it in statistics. I just got a couple more things. I know this is a little bit of a long lesson. All these lessons here at the end are pretty long, but want to talk about 2 more words. Number 1 is outliers. That's on page 556. What is an outlier? An outlier is something that lies outside, okay? A value that lies far outside the normal distribution. So if I have 1, 3, 5, 7, 63. What is that 63 doing in there, right? That is an outlier. That thing is outside of the normal distribution. These things are close together. They're all single digits. They're very close. And then boom, 63. What is that guy doing? He is an outlier. And I'm going to show you some ways that we can kind of marginalize that outlier. Some things, we don't really get rid of the outlier, but there are certain things that we can do that will help us to not that it won't affect us as much. So that outlier would really affect the average of that one, right? Because you're adding 63. The next thing there is the word range. This is on page 557. The range is the difference between the highest value and the lowest value. So if I had 1, 3, 5, 8, and 10. The range is taking 1 and 10 and subtracting them. 10 minus 1 equals 9. The range is 9. In other words, there are 9 number possibilities between 1 and 10. That's the range of this number set. So that's how you would do range. Okay? Alrighty, well, that's all I have for you in this lesson. Hope you learned something. Try some of these practice problems. Go back there, find the mean, median, and mode, and see what you can do there. We'll see you later. Have a good one. Bye-bye.